work at a small SaaS company in the city of Antwerp called Beatswitch. We do festival and music event management software, which is really cool. It handles a lot about handling artists where they need to go host their show, or what they eat, when they need to pick up at the airport. We do a number of really cool festivals, which some of you might recognize from these slides. And it's a really small team, really fun atmosphere to work in. I've been working at Beatswitch for 3.5 years now, and it still really doesn't get old at all. Besides my daytime job, I also host the PHP Antwerp user group, together with these guys, which you might recognize. And we really don't do PHP specific, just a really broad kind of topics involved around web development. Besides, like Sean said, besides PHP Antwerp and Beatswitch, I also maintain the Laravel community portal, which some of you might know. I recently launched a newer version a couple of months ago. The logo is new since like the day before yesterday, which is really cool. And I still have like a lot of plans which I want to extend the platform, so it's like more of a forum. Now it's basically just a forum, but bring back some of the older features from before, which you might know. But I still have a lot of plans for, and it's entirely open source, so you can check out the source code on GitHub if you want. Feel free to contribute and create issues if you like. Okay, so this talk, I'm going to start off with a question. Who here builds APIs? And I literally want to see everyone's hands, because like everyone has ever probably built some sort of an API, be it a simple JSON stream, be it like a really big API with different endpoints and different resources and stuff like that. And it's so commonly these days that we have so many ways of building them. And I guess this talk is more of an opinion, I guess, sort of the things I learned over the past few years at Beatswitch and the way we kind of tackle the problem of building APIs these days. So you might find it interesting to also incorporate it that way in your specific workflow. You might find it not suited to your workflow. That's perfectly fine. It's like I said, it's like an opinion and just the things I learned at Beatswitch. The talk itself will be a little haphazard. It's going to be live coding, so I don't have any slides at all. These are like the fewest of them. So I'm going to switch screens a lot. I hope that's okay, but I'll try to keep it to a bare minimum. It's a pretty beginner talk, I guess. So if you know about Apiary and API Blueprint and Dredd before, you might not learn a lot extra, but I'll try to show some cool extras. Anyways, live coding, and I totally stole this slide from Freek, and I'm not even sorry about it. Let me switch my screen. Okay, so first, I'm going to start with showing you that I'm actually going to do everything on the Laravel app, which I'm running locally on Homestead. And what I want to start off with is just showing you the way that people usually create APIs these days while working with Laravel, the most commonly way. So you might start off with something like make a test, let's say in the API namespace, and let's say for Laravel TO we have form threads, so let's make a thread test. Let's go there. So we have this basic test which we're using. That's actually the wrong class, sorry. Here. And let me change this real quick because I really like this syntax, just like Jeffrey does. And let's say it can return some threads. And let's say we're calling an endpoint, just threads. And actually, I need to put API before that. And let's assert that we're returning some JSON. I don't nearly type as fast as Taylor does, so sorry about that. I have no idea how the hell he can type so fast, but I'm trying, like, guys. So let's say a thread has an ID. It has some kind of subject, like foo subject, and it has a body. Like I said, I type really slow, really sorry about that. So, and we actually don't need any of this. We actually need that. So, when I run this test, let's say PHP unit, tests, feature test, API test, thread test, it fails because we haven't found anything yet. And when we're actually going to implement this endpoint, we're going to our API routes, of course. I'm going to uncomment this and kind of prepare this. And I actually need to make sure the content is the same, because otherwise it will fail. So it succeeds. So this is probably how you handle, given that the examples are really simplistic, of course, but this is the basic way of how you build APIs these days, and it's a nice way. We're writing tests. Adam will be so proud of me, and it's a good way. You're writing tests. You're defining what your API should be about, how it's structured, what data it's returned, and it's a good way. But there's some things that kind of bother me with it. It's first and foremost, it's really tied into your framework. You're writing a PHP test, you're writing it with a class that's tied to your framework. It's really coupled to your code base, and for me this is readable. You can perfectly get a gist of what's going on, what's happening here. It's very readable. Laravel makes it really readable, but there are some things here that kind of get in the way, like the public function, like the namespace, the PHP opener, the namespaces. It's stuff that doesn't really need to be there when you actually just want to see what the API is about. And at BeatSwitch, we kind of looked for a better way to building APIs. We were always hosting these meetings, these technical meetings, where we were saying the front end was there, back end was there, and we were saying, okay, so the API should return this sort of JSON response, this particular form. We'd write it down somewhere, wouldn't really get shared between others, but the front enders, when go and you were okay, it's going to be almost something like that, and you went on and went on implementing stuff, and in the end we kind of had to figure out how we would actually make the end result really match, and that was kind of cumbersome. So we kind of looked for a better way to doing that, and the thing that we discovered was not to write tests for your data structure, for your API data structure, but to write specifications. And a specification is actually a different way of telling what your API structure is about. So it's kind of a way of defining your endpoints, the expected results, the responses that you get back, and testing that specification against your API instead of manually writing tests. And it's a really different kind of approach, because I'm going to show API Blueprint in a bit, but it kind of decouples everything, how you define APIs from your code base, so you can share it around with others. Non-techie people can add to the API how they see stuff. It's really easy to share such a document and sharing these kind of tests. And the thing I'm going to show you today is API Blueprint. API Blueprint is one of the, I guess, more commonly known specification formats. You also have Swagger and OpenAPI, which actually is Swagger. But it's for me, API Blueprint was a much easier way to define such a specification. It's basically just Markdown that you write, that we all love to write as developers, which is really readable, parsable, and can be shared much easier between stakeholders. It's easy to get set up, easy to get started. It doesn't really require much upfront knowledge besides knowing how you define an API, how you define resources and stuff like that. It's really powerful as well. I still haven't grasped the full potential. I'm still learning a lot about how to make use of it. So it's really cool. And what I'm going to do right now is just to show you how we can transform this one we wrote here to such a specification. So you might notice that I have an apiary. Let me check real quick. I have an apiary.apb file here, and that's basically APB is APIB is the extension for an API blueprint file. And what we have here is like the header part of where you tell what your API is and what format it should be, what the host endpoint for it should be. And so how you tackle this, how you would implement the same thing we did last day, is basically you just write Markdown. So at first you define the resource. So you'd say like threads or something, and you define which resource that actually represents. So we're really like using a RESTful way to define all this. And then you would define like method calls, like actions against your API. So we would say something like get all threads or something, and that would be a get call you did. And of course, when you define a method, you should define what kind of response you would expect back. So you would do something like response, tell what status code should be, say what format it should expect back, and then after that, I'm actually just going to define here in JSON. So I'm just writing JSON here. Just going to say the same thing. Subject, test subject, and a body again. Full body. And this is actually all you need to define what you expect from your API. So as you can see, this compared to let me see here. This, in my honest opinion, it reads a lot better. It's much more cleaner. You only have things that are involved around your data structure for your API. Nothing else gets in the way, language specific. Really cleans up and gives you much better breathing room to define your API. So let's take a look at how we're actually going to test this. We're going to use some tool called Dredd to test this. And Dredd actually, think of it like PHP unit, but for testing specifications. So it's just a testing tool. It's it works with the two most commonly specification formats, Swagger and API Blueprint. And it's the nicest thing about Dredd is that it's language agnostic. So you can really use it in a lot of other languages like Go, Ruby, Python, PHP. And that's really cool. You're not tied anymore to one specific language testing tool. So let's just see how we're actually going to. And I have Dredd installed here normally. Yeah. So first thing we're going to give it is the API blueprint file which we're using. And then what I need to do is give an endpoint where it can verify the API against, verify the specification against. So because I have Laravel running on Homestead, I'm just going to use that to test things out. Let's run that, see how it works. And it works fine. Passing. It's like I said, it's just a testing tool like PHP unit, but to test the specification against. And this works really well, actually. It's just a little different mindset, but you get a lot of benefit. You can extract what you actually want to tell people about how your API works. And later on with Apiary, I'm going to show you how you render this in documentation and such. And you really just focus on the bits and parts that you actually care about, and not about the language-specific stuff. You might notice one thing in this, and that's, for me, one of the biggest gotchas what I had when learning about Dredd and specifications like that. Notice how the content here, and I hope it differs, yeah, it differs from the content I defined here. So why is that? Why does my test still passes even though the content is different? Because if I change this and I would run PHP unit again, normally it should fail because the content is different, and the assert JSON method expects that both the data structure and the data itself is the same. And the reason for that is because specifications, they aren't about the content of your application. They're purely about the structure of your API. They need to verify that the structure of your API actually is the thing that you expect, but they don't care about the content. Like, let's do a little test. Let's see if everything still works. Okay, that works fine. What would happen if I disabled this? Would it pass or fail? 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 It passes. Why does it pass? Because what you specified in the API blueprint file, you're expecting back a collection. And you're expecting back a JSON response and a to-under status. And you're expecting back a collection. But the actual objects in your collection doesn't matter. You can get an empty collection back. It's fine. It's a normal result set of your API. So this is a really big gotcha I got in the beginning, which I had to wrap my mind around. It's not about testing data, it's about testing structure. Structure of your API, making sure that everything works. And you really don't, you really don't test scenarios out with your application. You do test ways of getting back different sort of responses, like error responses or like when unauthorized statuses, stuff like that. So you can document in your API, get that specific structure back to tell your consumers about. But you don't test like, okay, when I do this, I need to get that kind of content back. That's still something you need to do with your framework tests, with integration or unit tests or stuff like that, but not with specifications. And that's something to really keep in mind. Now, Dredd and API Blueprint work really fine together. But for me, one of the things I really liked and took a further next step was when I discovered Apiary. And first I want to say I have no affiliation whatsoever with Apiary. I'm not trying to sell anything here. So I'm purely speaking about my own experiences with the platform. Apiary is a really nice, powerful collaboration tool, I guess, a platform. It's sort of the same way as Swagger Hub, which is for Swagger, but also handles API Blueprint. You just need to use whatever is fine with you. But I really like Apiary. And what it actually does is, you might notice Here on top left, that is basically the document which we started out with. It gives you a lot of features which you can use to build better APIs and build APIs in a better way, in an easier way. So you have an editor where you can work on APIs. I'm currently using a read-only mode for this particular branch because I don't want to like edit stuff here and break it on the GitHub code base because it's connected to your to a GitHub repository, for example, so you can actually sync your documents into the tool. You can, for example, use different branches, which is really cool. For example, if you had like a master branch and you would sync it against Apiary, and would use the documentation feature here. It gives you a really way of sharing that your API, what's it about. And this is just a rendered specification file. So everything you adjust in your specification file and share, it basically gets rendered into pure, clean, readable documentation, which is really nice because if you had some sort of CI workflow, which made sure that your master, your production branch is also always the same, it actually makes sure that your documentation is up to date with what's on production. And it's really powerful and really cool. Anyways, I'm going to like try to show you how fast it is. So when I like commit the stuff and push it to GitHub, oh my God, this Wi-Fi is so fast. I'm actually using hotspot, sorry. So I pushed it, and it should be like pretty fast, I guess. That's not good. Ah, yeah, okay. So what we wrote before, because I'm syncing to a specific Dredd branch at the moment at the repo, it gets updated almost instantly. So it's really nice to get that result back in the Apiary fast enough so you can check out. You can check generated documentation on the right here from the editor. You can check out the documentation itself. And there's some more cool features about Apiary, which makes it really worth paying for it, actually, because given a lot of these features which I'm showing you right now are paid for. There is a free tier, but it's not like super extensive or anything. Anyways, the inspector here, that's one of the really cool features about Apiary. What you could do with it is, for example, say you have a feature branch which you're building your API on, but you're not kind of ready to like implement the backend or everything. You could like define the specification for the API before with your front-enders, back-enders, make sure that the specification is okay. Push it up on a branch to get started with. And people on the front end would, for example, just use this. I'm going to copy this over real quick. They could just consume this API. Oh, crap, sorry. So they can actually start implementing front-end immediately, or whatever consumer interface you're using. And that's really powerful because as long as the specification still is valid and gets checked through a tool like Dredd, backenders can later implement everything, make sure that everything matches the specification, and everything would theoretically just work perfectly, which is really cool. And this is something that I learned at BeatSwitch, which really helped us out. Remember the technical meetings? Like everyone was discussing, like this is how the responses should be, this is how we should structure it. This gives us a really nice way of defining the structure of the API we're talking about, having everyone consume the same thing, and implementing it later on. And it's actually more of the mindset of designing the thing you're trying to implement first and implement later. So think about what you're trying to build first, implement later. That's a really big concept. So there's more stuff with Dredd you can do, like, for example, It has a really cool way of providing a better readable format for your test results. Because if I would like do, well, let's just break this real quick, and I would get like, yeah, okay, I know where it's wrong. I didn't put this back. Sorry. So if this breaks, you kind of get like a really long list of content, which isn't like always readable, especially if a lot of things break. But if you would like to run this with a reporter, and one of the reporters you can use is actually Apiary, you kind of get a really nice way of seeing that result of your test in a really readable format. So this just gives you a really nice way of digesting what went wrong with your test result, seeing the actual thing that's breaking, and really just gives you a really nice, convenient way of testing that. And this this actually also works really nice with continuous integration. So for example, imagine if you had a tool like Travis. I'm using Travis for continuous integration for Laravel. And what you basically just want to do is, let me switch real quick to the Travis file here. I disabled the other tests because they don't really matter for this talk. But what you're actually doing is just really simple. The same command you did before. You spin up a virtual server with PHP, which posts to the public folder. You add the reporter API, and what you get back is just a really easy continuous integration way of testing your API. And this works really fine. You can copy-paste the URL, given that this is secure, but like it's just your app name, and just check the results if anything breaks in Apiary. And Apiary also has a really nice and clean way of defining your local tests, your continuous integration tests, even post-deployment tests if you really want to do that as well. And it's a really nice and convenient way to just check out what failed. So we've seen how all of these things work separately. Let's just like recap real quick. So what I'm going to do right now is show you something really different. The examples I use, of course, are like really simplistic, but I'm going to show you a few more cooler things later on. Let's just say that we want to create a new thread here with a post request, and we want to like pass some data to it because we want some data to be created. So let's say request and give it a like an API response. We only need to pass in the subject. This doesn't really matter. I don't really care about this. And then what we're getting back is I'm just going to copy paste this. And I'm actually don't need it to be a collection, just need it to be a new resource. Let's change this to. I'm using SAS code of 201 for testing out for newly created resources. This is just a really small tip in between. I always check this site to see what kind of SAS code I need for my responses. And you can learn a lot about this. Like you can learn really cool SAS code. It's like where it is like I'm a teapot and something like that. I'm not really sure if anyone used that before. But yeah, cool. Anyways, let's check that if that works. And I also just prepared this before. Let's make sure this is the same. Okay, yeah, that actually doesn't matter, like I said before. So let's see if that works. Yeah, I think I know what I did wrong. I think this is still broken. Sorry about that. It's still not giving in. Post thread. What's wrong here? Subject is missing. Okay. Mm.
No, it's in the other specification.
This one?
Yeah. Down.
Ah, yeah. Oh, yeah. Stupid. Anyways, got bitten there. Sorry. Anyways, it's passing. You get your URL back. When I commit this, and push this, I don't really care about grammar at all. And it should get synced. Was maybe a little bit too fast here. Yeah. So your documentation gets updated. Your tests start to run. Let me see here. So your test starts to run. It's a really nice flow and a way of doing things. Things we are used to anyways when building new features and APIs. But just we're using different tools, different ways of doing things, and it's just a different mindset you need to take on. Okay, so I know that the examples I showed you so far are pretty simplistic, but you know, we usually don't always work with simple things. For example, at BeatSwitch, we have a public and a private API, so in one monolithic application. So we need to kind of find a way to define them separately and still get the same benefit of testing everything here and the continuous integration support and everything. I'm going to show you a way of how I tackled that at BeatSwitch. I kind of mimicked it here for a while over the real quick. But how I did this was I was kind of looking for a good way to define everything and keep everything together separate from the actual code base. So I came up with this API folder in the root of the Laravel project, and then defined a couple of other folders here. When I open the package.json file, you can see I'm just requiring Dredd here, which we're using to validate specification, and I'm requiring something called Hercule. And Hercule is actually a really simple tool, which you can use to combine files. So imagine if your API was like growing like really big, and if you go back to the Apiary file here, I only have one file here. So imagine if I needed to like implement the entire API for like a project that had like 100 endpoints or something like that. I would get like ridiculously big, unmanageable, unchangeable. And Hercule really helps with this in terms that you can like split up all the different files and combine them later. So what I did here, and I'm doing the same thing in BeatSwitch, is just to find a private and public folder. I have intro files, which I start off from, and they just describe the introduction, describe the specification format and stuff like that. And in those intro files, I reference the other different parts of the API, and I'm using Hercule to combine them. So if you look at this line right here, what I'm actually doing is just referencing the intro files and decided what the output should be. So I'm publishing the files to the build directory. So they're private and public, so they're together. So Apiary can read from them, because Apiary can only read from one file. That's kind of a downside. It's, but Apiary, the payment plan, has a way of defining multiple blueprint files, which is really cool. And that way you can like say, this is the public API, and this is the private API. Anyways, so how does that work? You basically, what I did was add the alias, like you said, run yarn build. And it's really fast. It's like almost instant that it reads all the files. Give or take, it depends on how many files you have, of course, but it's like really super fast. And that really works very well to like split up and structure your API better. There is like, they're currently debating at API blueprints of building native support for this, so like you don't really need to use a tool like Hercules anymore. But this gives a really nice, convenient way in the meantime for still doing the same thing. Okay, I'm going to go a little bit further here. One other thing I want to show you is called hooks. And they're a part of Dredd. And think of it as a way of defining like pre and after event sort of way of doing stuff. So imagine if you like in your API you wanted to define a way of authentication, like issuing a token so a user could like access a private API and still validate that through the specification. Or think of it like you can use them for seeding data, migrations, running transactions, stuff like that. They're really, really handy and convenient. And the way I use them here is how I define them. I just have a folder for the private one. I don't have any hooks for the public part at the moment. And I start off with this file, which is just loading in the composer files, bootstrapping the application. And the hooks file, in this for the private API part here, defines a way of setting an authorization token. I just like dummy pasted this real quick to give you a simple example. It just makes use of, let me see here, API, just a really small middleware that I wrote to validate against. In a real life situation, we would of course use something like Passport or something else that generates tokens. But this was an easy way to quickly define this. Anyways, let's see how the API is structured first. So I'm going to go back here, go to the users part, and as you can see, this is just the part of the user's resource. There's nothing else here. And I haven't really said that I need to issue a token here. You can do that as well. But the most important part is that when I go back to the API file, and I prepare a little route here, you can see that it requires a middleware. So the middleware that we defined before, and it has a prefix private to know that every endpoint underneath this is for the private part, which is just consumed by the application, not publicly available. And this, how you would test it, because I just wrote an alias for this. And you can see there's a lot more going on here. I installed the hooks through Composer just. I need to reference the hooks file itself, the binary, to run the Dredd command against. That it knows that it's digesting PHP, another language. And I need to reference the hooks, which are loaded in through a single file. So let's try that. So let's try yarn private, which is like 10 times easier than writing the entire thing. And it passes. And to just prove to you that it actually ran the hook, I'm just going to disable this. Let's see. And it fails. It throws me unauthorized now. So hooks are really a great way of defining stuff you want to do before testing your API or after. You have a lot of different hooks you can use. Let me see here. I don't know if that's readable. So you have quite a lot. You can run stuff before every endpoint, before specific endpoints, before each validation. You have some events to listen against, which is really cool. OK, so almost ready to wrap things up. Just to show you one more thing you can do with API Blueprint, because this isn't really talk about API Blueprint, it's more of talk about Apiary Dredd. But the examples I showed before in the API Blueprint file, let me grab that real quick here. They're just like, I'm just defining JSON. But like that kind of get cumbersome when you have certain data structures which you reuse a lot. And API Blueprint actually provides a really nice way to define those. So you can define data structures, you reuse them throughout your endpoints, throughout your responses and stuff like that. You can define them like this. It might be a little bit small, sorry. So you can define them like this. So you can reuse and kind of stuff throughout your API blueprints. And that's just like the tip of the spear. Like API Blueprint is really powerful. I'd suggest like you take a look at documentation to the specification. And you can find a lot of more cool ways to actually use it. One final thing I want to talk about is versioning, because I get that question a lot. Imagine that you're doing versioning through the route part of your API, like V1, V2, stuff like that. There's really no way of actually doing it otherwise than copying, than making a different specification for it, because the route part is really coupled against the actual definition of what the host would be and stuff like that. It's really coupled that, so you need to define a different specification for that, which kind of sucks. Well, I suggest, and personally, I'm a real favorite of versioning through headers. So through headers, it's no problem. You can just define different headers in your responses, still use the same specification. So you have, like, for example, a specification for V1, but you can still show different responses for V1.1 or stuff like that in the same specification. And that works really well, actually. So that's actually one of the final things I would like to mention. So to wrap things up, just going to do a really quick recap. Try to use a specification again, instead of tests, if that's applicable. Not all application needed, of course, especially like really small ones. For our kind of application, it was really a real benefit to switching to this kind of format. Detach from your code base, so it's not tied to any specific language, so you can reuse it later if you want. Focus on collaborating, sharing more about data structures, so you're not tying or anything specific to anything. And design first and implement later. Think about the thing you're trying to build first, then implement. And in the end, I would like to just say one thing. There's not really a right way of doing this. Like, this is the way I kind of sort of do things these days at work. I'm sure that there are a lot of different ways of building APIs, and this definitely isn't like the holy grail or anything. Anyways, I wanted to thank two different persons really well. Hans Jeverek, which is the maintainer of Dredd. He works for Apiary. And Dom Del Nano, which is the maintainer for the Dredd PHP hooks package. They've both been really, really patient with me, asking lots of questions during my search of learning these tools, and I really would like to thank them for helping out. That's basically it. Thanks for listening. I hope you learned something. If you have questions, I guess there's still time.
Well, you mentioned that the Dredd test would not check out the content of a response. How about if you want it to return a specific type, like a Boolean, but then you get an integer?
I actually forgot to mention that. I'm really sorry. I'm going to like switch really fast back to my code. Let me show you. So it's actually here. So what you would want to do, because you can't like put validation stuff in JSON responses, you would actually just use the data structures. And the data structures actually allow you to require some stuff, like the type of content you're expecting back, if it's a Boolean or an integer or a string, and if this certain attributes are required, but not all of them. So you just define it like this in the objects. And you can still validate that the type of data you get back is correct, but not like the actual data. It doesn't need to be hello world or 24, because that actually doesn't really matter that much. Hope that answers your question.
Yeah. Thanks.
Yeah. When you Yes. How would you make sure you get actual
data? Like when I showed the empty collection, you mean? Yeah, that's a really good question. Like, I've been bitten a number of times by that. Like, I was testing endpoints, and they were succeeding while actually no data at all got past back it. I'm still like searching for a really good way to actually verifying that. I think there's a way of defining it through the hook somehow, that you're actually making sure that the data gets seeded. But you need to get your keep your seeders in check and the data you seed before it. That's a really good question, actually. Yeah. Sorry, I can give you a better answer.
Okay,
yeah.
thank
but
you.
it's definitely you need to keep in mind when doing these kind of things. Yeah. Yeah. So the question is, if I got it right, to prepare certain data for a specific endpoint. That's that's something you can do through the hooks. So you would just write a specific hook for that endpoint. You would seed data through the before hook, to make sure that the data you actually want for that endpoint is correct, and you would use it like that. Does that answer your question? And that's for a specific endpoint? Yeah, that's for a specific endpoint. So this is that might not be entirely. This is the group. You also have a way of defining groups in your blueprint files. This is the resource, and this is the action you do. So they're the titles of your Markdown file. They need to be the same and match in order to do that. Hope that helps. Yeah, thanks.
Do you know any tools maybe for scaffolding? You have the specifications ready. Why copy paste the specifications to code?
You mean like generating code? You mean? Yeah. That's a really good question. I haven't actually checked that out yet. But if you're looking for tools to work with API Blueprint, there's like, I actually had this tab open and didn't show it. There's like tons of tools to help you about. Like the ecosystem is like really big. You have a lot of different tools. And I just suggest look at this page. Maybe you find what you're looking for. I'm pretty sure someone has thought about that before. So,
thank you.
Yeah, okay, thanks.